Hello guys, today we discuss about a new chapter, that is conic section. So what do you mean by conic section? You know a cone is there. A cone, suppose this is the picture of a cone. This is the picture of a right circular cone. This is the axis of the cone. This is the axis of a right circular cone. You can see in your picture that this is the apex or vertex of a cone, and this is the base of a cone, right circular cone, and these are the generators. These are the generators, means we generate. So this is a cone. And conic section means if we cut the cone, if we cut a right circular cone by a cutting plane, and the sections, whatever the section we got, that section is called conic section. So actually we discuss here about the conic section, that is ellipse, parabola and hyperbola. Mainly that is, which is in our syllabus, that is ellipse, parabola and hyperbola. So how we can get an ellipse? When the section plane is inclined to the axis and cut all the generators on one side of the apex, then that section we got, that is called an ellipse. That is called an ellipse. So this is the axis of a plane. I have already told you that when a section is inclined, the section plane is inclined to the axis. This is the axis of the cone, and suppose this is a section plane, that is just like this is a section plane. Suppose this we cut, this is a section plane, understand? So this is a section plane. So we cut this ellipse and remove the top portion in this way. This is the cutting plane, means this cutting plane is inclined at an axis and cuts the total generator. These are the generators. Cut the generators on one side of the apex. So this one is the apex, this is the apex. So we cut, remove this portion, and whatever we got, that is an ellipse. So I want to draw this portion. Suppose this portion from here, just like this, you can see here. Suppose this is the, I want to draw the three-dimensional view, just like this. You can see here, just like this, and whatever we got that portion. If we cut this, we can get this portion, and this section plane, this is the section plane, cutting section, and then we got an ellipse. Understand? Means when we cut this right circular cone by a cutting section and remove this portion, then we got the cutting plane, that is the section plane, that is an ellipse. This is the section plane. Similarly, when this is an ellipse, this is the cutting section plane is an ellipse. This is an ellipse. Similarly, if the section plane is inclined to the axis and is parallel to one of the generators, then the section is a cutting section is a parabola. It means that when the section plane, suppose this is a right circular cone, this is the axis, this is the axis, and if the cutting plane is at an angle with the axis, suppose this is the cutting plane at an angle with the axis, and it is parallel to, suppose this is generator, this is another generator, it is one of its generator. So if we cut this axis by this way, we cut this axis this way and remove the portion, then we cut this portion. This cutting plane is parallel to the one of its generator. So this generator is parallel to one of its generator. Then we got just like this. I want to draw a just like this. So if we remove this portion, then the rest portion is that, and the section plane is what? This is the section plane or cutting plane. You can see here, this is the cutting plane, and this curve is called a parabola. Understand? So this is a parabola. Parabola. So we can get this. And again, when the section plane cuts both the parts of the double cone on one side of the axis, then the section is a hyperbola. Means this is a right circular cone. You can see here. This is the axis of this right circular cone, and we cut one side of its axis just like this. We cut this portion, remove this portion. This is the cutting plane, and we remove this portion. Then we got a section that is called hyperbola, just like this. Just like so. This is the section plane, and this is what? This is hyperbola. Hyperbola. This is hyperbola. Parabola, and this is hyperbola. Understand? This is parabola and this is hyperbola. So these three are the conic section. Means we got, if we cut a conic by a section plane, then the section plane, the plane we got, that is the section, conic sections after sectioning the cone, right circular cone. So you can see there. Now, first of all, we discuss about an ellipse. First of all, we are discussing about an ellipse. So you can see in our drawing that suppose this is an ellipse, and we divide this ellipse into two parts, and this is AB and this is XY. So here this is an ellipse that is in your screen now, and you can see this is the major axis. This is called AB, is called the horizontal. Actually two axes are there. One is horizontal, another one is vertical. So this horizontal axis is called the major axis, and the vertical axis XY, that is called the minor axis of an ellipse. Similarly, I draw two straight lines just on both sides and 2 points here at the same distance, with the same distance from the minor axis, these two lines and these 2 points at the same distance from the minor axis. This is F1 and this is F2. Similarly, this is, suppose, D1 dashed, here is D2 and here is D2 dashed. So an ellipse can be defined as the locus of a point moving in a plane in such a way that the ratio of its distance from a fixed point to the fixed straight line is constant, and that is less than 1. That is less than 1. The fixed point, here you can see F1 and F2, the two fixed points, and the straight line to fixed straight line, these are the two fixed straight line, that is called directrix. So an ellipse has two directrix and two focuses are there, and two focuses are there. Understand? And the line which passes through the ellipse, these 2 points, this major axis which is passes through the ellipse, 2 points are there. So these 2 points here, this point is called V1, vertex 1, and this point is called vertex 2. This point is vertex 1 and this point is vertex 2. Understand? Now this is the vertex 1 and this is the point, that is vertex 2. Understand? Then what is the eccentricity? What do you mean by eccentricity? Actually, eccentricity is the ratio. Eccentricity is the ratio. It is the ratio of the shortest distance from the point on an ellipse and the focus, the shortest distance of the point, that is called eccentricity. The ratio is called eccentricity. Understand? So I am telling you and discussing all these things just like this. The ratio, that is, what is the definition of eccentricity? Eccentricity, it is denoted by small e, and it is the ratio, means the distance of the point from focus. Suppose suppose a distance, suppose take a point on the point, suppose C, suppose a point P, suppose this is a point P upon an ellipse, and it is the ratio of distance of the point from the focus to the distance of the point from directrix. So this ratio is called the eccentricity of this ellipse. Suppose so distance of the point from the focus, actually this is the shortest distance. So suppose f1, we take the focus f1, then pm, this is the shortest distance of that point from the focus, and if we draw a perpendicular distance from this point to the directrix, suppose this is S, so E of this ellipse is how much? It is a distance that is from the focus, means pf1 by ps, and it is, in case of ellipse, it is always less than 1. So in case of ellipse, eccentricity is always, you have to remember that in case of ellipse, eccentricity is always less than 1. Understand? So in case of ellipse, this is the picture of an ellipse. This is a curved section, you can see, and these two lines is called directrix. This is the major axis, this is the minor axis, and here we can see two focuses are there, two directrix and two focuses are there, and where the major axis cuts the ellipse, the points which cuts the ellipse, suppose this one, and these 2 points are called vertex. So I think you can understand this about an idea that is called ellipse. So thank you for today. I will discuss you later in the next day about parabola and hyperbola.